Hi everyone. I'm Nilesh, and with me my friend Zuhaib here. We are going to talk about data exploration in predictive analytics and our language as part of our assessment too in our course in VQUNI. Um, so starting with computer systems today store vast amount of data. Researchers, including those working on how much information project at the University of California, uh, recently estimated about say it was around 1 exabyte of data that is generated annually every year, including and this data had like 99.9% were yeah, not the, yeah, were in digital form. So the worldwide data deluge means that in the next 3 years, more data will be generated than during all previous human history. So the next 3 years would be equal to whatever we had like 20, 30 years of all. So yeah, deeper in the topic of data exploration, which is the key for this video. Um, yeah, data exploration is an approach similar to initial data analysis, whereby a data analyst uses visual exploration rather than just going through books to understand what is in a data set and the characteristics of the data with the help of graphs and everything, rather than through traditional data management systems. These characteristics can include size or amount of data, completeness of data, correctness of the data, possibly relationships among data, and elements or file tablets in the data. So mostly the way the data exploration is conducted is using combination of automated and manual activities. So automated activities can include data profiling or visualization, obviously, and then we have tabular reports that comes out, and to give the analyst an initial view, like you don't have to read deep into it. You can just visualize it and then make sense of the data and understanding of key characteristics. So this is often followed by manual. Obviously, there's always a manual input in everything. So by manual drill down or filter of data. So if you don't like the visualization, you manually remove some element from it to make more sense of it. To identify anomalies or patterns identified through automated actions. So data exploration can also require manual scripting and queries that we put in codings and everything. So and the language used by especially right now in predictive analytics, it's SQL or R enterprise. So we can also use like traditional Excel, which is the base of every language you use, and similar tools to view raw data. So furthermore, all of these activities are aimed to creating a clear mental model and understanding of the data in the minds of analysts, and defining basic metadata. So which means statistical, structural, relationship data for the data set that can be used in further analysis. Looking more into it, data exploration can also refer to ad hoc queries and visualization of data to identify potential relationships or insights that may be hidden in the data. So, but it never used to be the same. Traditionally, there had been like key areas of focus on statisticians, with John Tukey being a key evangelist in the field. Remember, we learned about him in our stats as well. Today, data exploration is more widespread and is the focus of data analysts. So and data scientists, obviously, and later being a relatively new role within enterprise and larger organizations. The phases of data exploration is fairly straightforward. Modulars need to find a good clean source of data, and number of records, histories, fields. Also, there is a good chance there is a pattern and relationship in the data that has significant business values. Yeah, on average, normally the research conducted suggests groups pull data from like 7.8 data source. Um, Normally it's 8.6, so this is quite genuine data that we have. And mostly the data that's present in the market, say market right now, it's mostly transactional data. The main ones are transactional data. Almost 86% is transactional data. Yes, it is hard to, collect the data and everything, but fortunately, storage, yeah. Fortunately, most of this data is already stored in our data warehouse. So minimizing the time to require to, search for data across multiple systems.
Yeah.
According to survey respondents, 68% of the data used to create predictive models is already stored in the data warehouse.
Makes it easy.
Yeah, makes it much easier, yes.
So what
so
types
there are
of data?
more like we've got tools that can be used to tackle predictive modelings and use a variety of tools to explore and analyze. Most analytical tools offer some exploratory capabilities. Basic tools enable analysts to, descriptive modeling and all that. And data profiling tools are common in data quality projects and so forth. I would very much like to know more on programming languages. If you,
I'll elaborate on it.
Yeah, if you want to elaborate on it, please.
So basically, what happens is we are doing the predictive analytics and we are using tools. So as part of our assignment, we need to this is one tool that is R. It's a programming language. It is used in predictive analytics to make it easier, more easier than it already is. We have the data. What R does is we have to install the software, like obtaining and installing. That is the first step in R. And the next step is we obtain the data set. So what we do is the data that, like you said, it's in data warehouses. So we obtain the data on which we have to work, like the relevant data, not the other data. Yeah. And then we prepare it, like R for I'm talking about in the context of R. Yeah. So we prepare it, we build a model and evaluate its power, like how it is, how useful it is, how it's going to work, and to what efficiency it's going to work. So based on all this, R provides us with a platform. It is an open source, to mention. So what open source actually means is it can be accessed by anyone. So open source basically means it's open to everyone. So what R is, it's originally basically a programming language that was designed for statisticians to do statistical analysis, including predictive analytics. So it is not only based on statistical analysis, it is it can be used for predictive analytics as well. So talking about it further, it's used in statistics, bioinformatics, economics. So talking further about predictive analytics, it is a very active community. More people are using our language as part of their predictive analytics thing. So whoever the data scientists, data analysts, they're using this tool as part of their predictive analytics thing. So the community is active. This software is being used. So the more the users are, the more data you have, the more knowledge about it you have, the more people around you can ask questions to. One thing there is very good about this thing is when it's open source, it's free, and if you are stuck with some problem, if you're analyzing data and you get stuck somewhere, you can just post a question. It's got Stack Exchange, Stack Overflow. That is a question, like a message board. So you just post your question and you simply have an answer to that. So basically what what I talked about is predictive analytics made our data exploration easier, like it made our data analytics easier, and our language made our predictive analytics easier. So it all is in line. So one helps this thing and the other helps this thing.
That was
And
pretty clear.
yep.
Thanks for that.
And to conclude our video, I'd like to thank Nilesh and
Thank you
for your time for watching this. You enjoy your day.
Thank you.